All right, 8.4, last section in Unit 8. Just a couple little review problems. So solving a proportion. Remember anytime you have a binomial to put parentheses around so that when we do the cross multiply, you remember to do this. So you're doing 5 times x minus 1 equals 3 times 2x. Not as really important there, but it definitely is for the binomial. So you remember to distribute to both parts of the binomial. So you end up with 5x minus 5 equals 3 times 2 is 6, 6x. If we subtract 5x from both sides, we get x equals negative 5. All right, I'm not going to work through number 2, but just remember it'd be those 2 times each other, so you'd have to distribute the 9 here and here and get 18 and 27, and here you get 12x. So if you want to work it through and for yourself on practice, that's fine. I just want to kind of cover the basic ideas. All right, so a couple new theorems here. Triangle proportionality theorem. So if we have a triangle and if we draw a line that is parallel to one side, okay, doesn't have to be the midsection, midpoint, or anything. It's not a median, a mid-segment. It's just any line that connects the two sides that's parallel to the other side. Then we have a proportionality. Okay, so RT, which is this section here, is proportional to RU. I'm sorry, my bad. Getting ahead of myself. That's a variation. RT is proportional to TQ. So the big piece on that side is proportional to the small piece. The same way RU is proportional to US. Okay? So it's a proportional relationship. So let's say this was 6 and this was 3. And let's say it wasn't, then, this would be 6 and this would be 3. Or if this was 4, this would be 8 because it's proportional. Okay? You get 24 either way when you multiply. The converse of that is if RT is proportional to TQ the same way RU is to US, then we know that these two lines are parallel. So it goes either way. All right, in the diagram, it says QS is parallel to UT. Okay, we have the triangles there. It says RS is 4 and ST is 6. So I can just say right off the bat, 4 is proportional to 6. All right, the same way this X is proportional to 9. All right. Now, if you wanted to do some kind of a word wall, you could do like words like, the upper section and the lower section. All right. And 4 and 6 are on the right side and X and 9 are on the left side. Whatever works for you. Okay. But the upper right is 4, the lower right is 6, the upper left is X, and the lower left is 9. And now we just cross multiply and solve. So 6x equals 4 times 9, which is 36. So x is 6. So we know this piece right there is 6. Okay? Determine if they are parallel. We're trying to figure out if this is parallel to this. So therefore, this piece should be to this piece the same way this piece, the smaller one, is to the larger one. Okay? Now, there's a few different ways to do this problem. You can cross multiply and see what you get. Okay? So if you do 50 times 72, you get 3,600. And if you do 9 times 4, that's 36 with 2 zeros. Checks out. Another way is if you reduce these, 5 over 9, and if you divide by 8 and divide by 8, guess what you get? 5 over 9, and those are obviously equal to each other. So there's a few different ways you can do that. The third way is you can do decimals. You can do 50 divided by 90, and you get 0.5 repeating. And you can do 40 divided by 72, and guess what you're going to get? 0.5 repeating. So a lot of different ways to prove they're equal or proportional, therefore the lines are parallel. All right, on the shoe rack, BA is 33, so you just could fill that in. CB is 27. CD is 44. And DE is 25. Explain why the shelf is not parallel to the floor. All right. Well, if we just look at this, you can just draw fractions right there. And basically, you're going to have 27 over 35 equals 44 over 25. Okay. Right off the bat, something should tell you that there's an issue, there's a problem. Because if you notice, 27 is smaller than 35, but over here 44 is bigger than 25. All right? So that right off the bat is going to tell you, this is a proper fraction and this is an improper fraction. They can't be equal. So you turn them into decimals, you would get less than 1 and greater than 1, not equal. You can also multiply them, 27 times 25, okay, and 44 times 33, and you're going to get 1,452 does not equal 675. Okay, so since the sides are not proportional, then BD is not parallel to AE. Okay? 3 lines theorem. If you have 3 lines that are parallel to each other, so see our 3 red triangles, if the 3 parallel lines intersect 2 transversals, they divide the transversals proportionally. So UW is proportional to WY the same way VX is to XZ. It's the same concept as we just had in the triangles, all right? Just slightly different. So in the diagram, 1 and 2 are equal, and 3 are equal, right? Which means what we have there are corresponding angles, okay? So we know that these 3 lines are parallel to each other because 1, 2, and 3 are corresponding angles, and CE is a transversal. Okay? So GF is 120 yards, right here. DE is 150. CD is 300. And we don't know this. Okay. It says find the distance of HF, but to do that, we need HG. Okay. Well, we have our fractions right here. 120 over X equals 150 over 300. Now, there's a shortcut here, if you notice it. 150 is half of 300. So this is really 1/2. So 120 is half of what? 240. That's one way to solve it. Another way is to do 120 times 300 equals 150x. When we do that, we will get 240. So that means this is 240, but remember, be careful what it asks for. It asks for HF. So you need to add those together. HF is 360 yards. Always be careful to make sure you know what it's asking you to do. All right, triangle bisector theorem. If a ray bisects an angle of a triangle, we've already talked about bisecting angles. It basically just means that this piece and this piece are equal, or this angle. Then it divides the opposite side into segments whose lengths are proportional to the lengths of the two sides. So this piece right here is proportional to this piece, the same way this one is proportional to this one. Okay? Now notice how I put AD on top, so this one's also going to be on top. All right? So here we go. We have an angle bisector. Okay? So what we're going to do here is we're going to say this piece is proportional to this piece, the two pieces, so 14 over x. Now, since I put the 14 on top, I'm going to put the 24 on top also, and 48 here. Again, there's a little bit of a cheat here. If you recognize that 24 is half of 48, then 14 is half of 28. If you didn't see that, you would do 24x equals 14 times 48, and you'll end up getting x equals 28. Always look for the shortcuts if you can find them. All right, we have an angle bisector again. Now, this one's a little tricky, and this goes back to why we reviewed at the beginning the binomials. The whole length here is 15. This piece is x. So think about it. If this was 8, how would you find QR? Well, you would do 15 minus 8 and get 7. Right? Well, we don't know it's 8. We know it's x. So this is actually technically 15 minus x. That's what we're going to use. So again, we do the same thing we did before. This piece and this piece. So 15 minus x over x. I have the 15 minus x on the top, so I'm going to have this on the top. And then I'm going to cross multiply. But before I do that, I'm going to put this in parentheses. So I'm going to get 7x equals 13 times 15 minus x. I need to distribute my 13 to both. And I'm going to get 195 minus 13x. I'm going to add 13x to both sides and get 20x equals 195. And when I divide by 20, I'm going to get x equals 9.75. And that's the measurement, and it's asking for RS. That's right there. Now, if it asked for both, then we would do 15 minus 9.75 to get the other piece. Simple enough. And that's it.